It's the last session of October, right?
Yep.
And then we don't have any more sessions until like the 2 that we're gonna do in December with a speaker that we decided.
Right, and I guess we also have that upcoming website session.
Yeah,
Right,
yeah, but that's separate from the Learn to Code.
right.
Okay.
Which I guess might be good to meet about.
Yeah, of course, yeah. Yeah,
oh,
we
sorry,
can.
we're live. I didn't even realize. That's okay
Okay,
too.
we meet. All right, so hello everyone. Let me make sure we live. All right. Okay, so hello everyone, and I'm sorry we are a little bit few minutes late. This is Celeste from the New Haven Free Public Library, and we are with Paige on the series Learn to Code, Create an Instrument. This is the last session of October. We're not gonna have any sessions in November regarding Learn to Code. He's gonna be doing one more separate, but then in December we will meet again to continue this series a little bit more hands-on. All right, so welcome, Paige.
Thanks, Celeste. Appreciate it. Yeah, so not only is this the last session of October, but this is the last session of the digital instrument series. So the subsequent installments in that series, like in December, will be some different stuff. So today I wanted to cover something kind of like I think very straightforward, very basic, but at the same time very, I think, pretty powerful as far as instruments go, or making instruments digitally. It's something that can really only be done digitally. So I think it's kind of a fitting way to kind of close stuff out. I hope it's a concept that is interesting or could be unfamiliar to you if you're joining us this time. So that's pretty cool. So I'm going to share my screen here. And again, last time, I don't know if we had problems with the audio. I couldn't particularly tell. But nonetheless, it might be something to clarify because I'm not really sure if my audio is coming through on the Zoom call. So maybe Celeste, you can let me know if you hear anything when we get to that point.
Okay, no problem. Yes, I will be here. Also, I will be here answering any questions. We don't have any attendees right now in Zoom, but I'm also watching the chat in Facebook. So if you have any questions, please let us know.
Yeah, awesome. Okay, great. So basically today, also just a reminder, in order to get to the notes for the session, go to github.com/Page Swanson /PD instrument course. So if you go here, this is like the top level. So this is the last session, session 7. So there's been 7 sessions so far. This is the 7th one. And if you go in here, there's a note file. You open that up, and then you get to where we are today. So today, basically, we're going to talk about sampling. So sampling is a concept that's pretty unique to basically the digital domain, or the sort of like the data domain, or however you'd like to call it. I mean, specifically digital sampling. There's other forms of sampling, but specifically for audio, typically sampling, when we refer to it, we're talking about digital sampling using computers effectively. Specifically, we're talking about the pathway for us to record audio or to recall a piece of audio, some kind, whether that be from like a person talking or singing or something like that, with some kind of input device. There's got to be some way to get it into the computer. And then the idea is to figure out how to represent that audio digitally, so that then you can play it back on the computer out to your speakers. So I mean, this is sampling, basically. Like, you know, we're sampling actually right now, or we're hearing the process of sampling in action. I'm speaking to you over Zoom, So my computer is sampling my input from my microphone, and then it is reproducing it on your end, wherever you are listening to this audio. So I mean, that's sampling. So that's what we're going to talk about. And in Pure Data specifically, we can create instruments that take advantage of the sampling behavior inside of our that's happening as we record audio, as we stream audio. But also we can do some very controlled sampling of our own. So we can kind of we can basically resample something and then play it back, which is pretty interesting. Okay, so again, sampling is the practice of extracting portions of an audio signal for reuse. I mean, that's just one definition of it. If you go to this Wikipedia link here, you'll see some other definitions and some more thorough explanation. Yeah, I mean, this is a pretty interesting way to do it, the reduction of a continuous time signal to a discrete time signal. The point being, you know, we often describe audio or sound, let's say sound instead of audio. We often describe sound as a continuous time signal, meaning like it's happening in our experience of time. You know, as someone's talking, or you're listening to someone talk, or you hear some audio, you can't really like break it apart into little pieces. It's your brain interprets that audio continuously. We all kind of experience it continuously. But for a computer can't do that. A computer has to break down each of those little pieces of the sound, and that's when we get into the territory of like audio. I mean, or signals. So that's this idea of sampling. So typically we do this in real time, especially for instruments like I'm talking about today. So when we use it in the context of an instrument, when you hear people talk about like sampling in terms of like, you know, like for a song, like a popular song or a piece of music or something like that. I mean, especially for contemporary music, where you talk about artists sampling other artists and things like that. Usually what we're talking about is basically kind of like real-time sampling and rearrangement of the sample, or not necessarily real-time maybe even, but the idea would be that you're recalling a portion of audio for playback in a different context, stuff like this. So when people say sampling in that context, though, they're usually referring to like, oh, I sampled this person. I got a sample of that person. So let's take for example, like if I have a sample of someone else's track, something that someone else recorded. If I sample it in my song, we might call that sampling when I take just like a particular part of a vocal or something that someone else recorded. But that's not what we're talking about when we say sampling here, or I refer to a sample. When I refer to a sample in this context, what I'm talking about are basically the smallest portions or the smallest components of a digital piece of audio. So like if I play a digital audio file on my computer, when I say sample, I'm referring to like the tiniest fragment that the computer can interpret from that piece of audio. So I'm not referring to like the whole thing, like, oh, this is a sample. When I say a sample in this context, I'm referring to one basically instantaneous point that the computer is using to build the audio signal, you know, after it plays many, many thousands of these points in succession. We'll kind of see more practically speaking what this looks like, what this process looks like, because it's a little bit unclear when we're just describing it. And that being said, understanding what a sample is again a little bit easier in practice, but to be clear, it's not that complicated, an individual sample alone. A sample is really just a value for an amplitude of the audio signal at some point in time that the computer can like understand. So, you know, if I have some sound happening in the real world, like my voice talking right now, the way the computer sees that is thousands and thousands of basically little values all in a row, representing the audio over time. So if you were to line them all up together in a row, they would be changing over time because the volume of my voice, the frequency of my voice is changing as I speak, etc. So when I say a sample is just a value, it's just one of those little points, like over time. And that's all it is. So it's literally, you could think of a sample as just a number, but it really has two pieces of information that make it a sample. I mean, the number, which indicates the amplitude at that point, but also the time at which that value occurred. So that's kind of what makes it a sample. We can capture samples. Oh, that's a typo. Just ignore that. We can capture samples very frequently for a better picture of the frequency content of the audio we're working with. So we talked about frequency content last time being like pitches and things like this when we talked about filters. If you didn't catch that, that's okay from the last session. But basically, you know, pitches and things like this, you know, if I change the tone of my voice or the pitch of my voice, you know, basically, if I want very high resolution understanding of all of the different frequencies that are present, I mean, basically just talking about recording quality. If I want a high quality recording of something, often people are referring to sample frequencies. So this is basically, if I want a better quality representation of audio that I'm trying to capture, right? A sound I'm trying to capture, like my voice, right? I could increase the sampling frequency. And what this means is basically, instead of capturing like, you know, X many samples to represent this audio, I'm going to capture 10 times that. So there's more data representing that same period of time. This is a really important concept in sampling, which we'll talk about as we get into actually doing this little implementation. Last part of sampling that's interesting, it's not really going to come up here in our implementation too much, but I thought I would mention it. There's also this idea of the resolution of a sample. So if you think about a sample as just being a value at a certain time, let's think of just like a wave, maybe traveling like this. If you can imagine just a wave, like a sine wave, going from +1 to -1 to +1. You know, the sine wave travels, it doesn't travel immediately from 0 to 1, right? It travels on a curve. So it goes from 0 to 0.1 to 0.12 to 0.16 to 0.1, you know, it travels over this series of values to arrive at 1. And that's what the sine function describes. It describes how to get from 0 to 1. But the problem with that is how many possible values do you choose to represent between 0 and 1? We could represent like 0, 0.1, 0.2, 0.3, 0.4, 0.5, etc. And that would basically be, you know, like 10 possible values. So I represented 10 possible values for a signal. That would be very low, what would be called sample resolution. So most people, you've probably heard of like a 24-bit audio recording or something like this, or a 16-bit audio recording. I think traditionally MP3s are like 44,000, or I'm sorry, 44.1 kilohertz, or 44,100 samples per second. And usually the bit resolution is like 16 bits, meaning basically I can have a very large range of numbers to use when I create a sample. This is, again, still pretty out there, but if you read this Wikipedia page, you can kind of understand what's going on. Or actually, there's actually a really nice diagram here. I don't know why I'm making it so complicated. So if you look at this, the idea here is that this like green wave, actually, I'll just click the picture. So the idea here is that this green line represents like the sound wave. Okay, so this would be a sound wave over time. And this is time here. So this isn't in seconds or anything. This would be like in some maybe nanoseconds or something like that. I don't know, milliseconds, let's say. So 1 millisecond, 2 millisecond, 3, 4, 5, 6, etc. This wave is traveling continuously over time, like as we're hearing it in the real world. But the computer is doing this. So what the computer does is it samples at regular intervals, the value of this changing signal. And then the computer stores this as samples. So this little line with a dot, this line with a dot, this line with a dot, these are samples. So this is one sample, this is two, this is the second sample, the third sample. So the sample occurs at some time, t, which here you can see the t label, and it has some value, which they're calling s of I, but they're just saying basically the value at this time. So this value, you can see it changes, right? Like it's varying over time, like it just depends on what the signal does. So we want to represent as many possibilities for this value as we can, which is why we would want high, what's called bit resolution. The word bit is coming from binary, like computer representation of values. So you could really just think of it as like number resolution. So the higher resolution you have, the more possibilities you can sort of represent. This improves a lot of people when people talk about recording engineering and like audio recording and stuff like this. This improves dynamic range. Terms like this come up, and it also improves frequency content as well, the presence of certain frequencies, etc. But it's an interesting concept, generally speaking. So basically, what we're going to do today is make a very, very basic sampler. What's funny about this, especially using Pure Data, is Pure Data is already doing sampling, because that's how it is able to reproduce audio out of your computer or play back audio, and that's how you use your microphone. But basically what we're going to do is we're going to pretend that we have our own little sampler inside of that, which is going to be kind of interesting. Okay, so first thing I'm going to do is I'm going to start a new file like that. And I'm going to go ahead and zoom in, doing Command plus or Control plus. All right, so the first thing I'm going to do in order to set up my sampler is I'm going to set up a way to record audio. In order to record audio, I need to add this new object, which I don't think we've ever worked with before, at least not to my knowledge. We're going to work with this ADC tilde object, which should look really similar to the DAC object. The DAC tilde object is the output for your computer. This is the input to your computer. So this is the analog digital converter, or analog to digital converter. The idea is that it's going to take something analog, which would be my microphone on my laptop, or actually it's going to be this microphone right here, and then it's going to convert that, actually using sampling, to a digital signal or a digital representation of the signal. So let's go ahead and add one of those. So I'm going to put an object called ADC with a tilde. Okay. All right, so before I proceed any further, what I need to do is make sure that my microphone device is configured correctly, which is it's pretty simple to do this. You just go to Media, the Media ribbon at the top for Pure Data, go to Audio Settings, and select the microphone that you want to use. I'm just using the built-in microphone, so I don't need to do any configuration change, but it's just to confirm that that's how you want to do it. So, okay, so I hit OK, so that's good to go. Okay, so that's all we do. That's all we need to do to get audio recording into our computer. The second thing we need to do is we need to make a table So we created tables before. If you've been in part of previous sessions, you know that we often create tables in order to preview a signal. So we like observe a signal, like see what it looks like as we're playing it back, which is really helpful for debugging our patches and for modifying our instrument. So in this case, the reason we want to use it is we're actually going to use it to store the signal samples. So we're going to store our samples inside of this table. Okay, so the way we're going to do that is using a tab right. I mean, pretty much we're going to do it the same way we do it for storing like signal previews, visual previews of our signal. So basically, I'm going to add a new object here. Object. I'm just going to actually paste what I just copied, except I'm not going to use the word table name. This is just a substitute. So I just need to call it something. Then I'm going to call it incoming, just for simplicity's sake. So now what I can do is I can send the ADC output into this tab right. Now the ADC has two outputs. That's because I guess it assumes I have a stereo microphone, I think. Is that true? By default, they are stereo. Yeah, okay. So it expects that I have a stereo microphone, which I don't think I do. I think it would just be mono. So if I grab this too, I'm not actually sure what would happen. I just don't even worry about it. Just grab the first one. So this means basically now we're going to write everything that comes out of this ADC into this table called incoming. Now, of course, we need to actually make a table to store all of this information to. So for that, we're going to need an array. And it needs to match this name here. So I'm going to put an array. And this is pretty important. So as soon as we open up the option to create an array, we get this properties menu. This properties menu is going to let us dictate how large the table or the array is for storing all of our samples. So basically, what you should think of this as is how many samples do I want? Okay, and then you also need to think about how long do I want my audio? How long do I want my audio sample to be? Like how long should my audio sample be? You know, if I'm playing it back, like yeah, hopefully that makes sense. We'll see in a second because it probably isn't super clear because we haven't really talked about that. But let's take a look back at the audio settings so I can see what value I'm going to use. So basically, what I want to do in this example is I want to sample exactly 1 second of audio. Okay. What I'm going to do is go back to media, audio settings, and I'm going to see what my sample rate is. The sample rate is provided in units of samples per second. So if I want exactly 1 second's worth of audio, of a discrete signal, a digital signal, then I need to store exactly 4,000 or 44,100 samples. So I need my table to have a size of 44,100 samples. So if I want to be able to store 1 second's worth of audio, if I were to change this sample rate, like if I were to increase it to any of these values, which are just typical sample rates, or if I were to say, you know, we'll mess with that a little bit later. But basically, if I were to change this, then I could change the size of the table. I mean, we could get a really crappy quality sample even by going with like 8,000. If we did 8,000, then we can have a second's worth of audio with only 8,000 samples, which would sound pretty poor quality. Like it would not capture very much, but that's actually pretty close to what telephone quality audio is. So if you've ever wondered why telephones kind of sound not great. I mean, there's other reasons why they don't sound great either, but they sound very good specifically for human voices. And they actually chose a sample rate that makes sense for the human voice in particular. So, but you wouldn't use 44,000 samples per second for telephone audio quality. It doesn't need to be that high quality, so they don't use that because it's expensive. All right, so I'm going to leave it as 44,100, and then we'll experiment with different ones in a second so you can see actually what we're doing. But what I need to do now is I need to create this array. Did that go away? No. Okay, great. So I'm going to make this array. I'm going to call it incoming. And then I'm going to set this to 44,100. Okay. And save that. Okay. So it's just going to be blank for now because there's nothing coming in yet. There is actually something coming in, technically speaking, right? Like if I turn on DSP, technically my microphone should be writing to this table. But now we've come to the second part, right? Like I have to tell table write when to write to the table. So I have to indicate to table write, this object, when to update the content in this table. So I'm going to turn off DSP for now. Okay, so we talked about sample rates, etc. We'll get to that. Basically, what we need to do is now we're here. What we need to do is basically say to the table write, start recording, record for exactly 1 second, and then stop recording. So the way we do this is with a couple of little tools. If you've been in the sessions before, you should know what these things are. But if you aren't, that's okay. I'll kind of describe them as I go. The first thing we need is a couple of messages. Messages, again, are just little nodes in pure data whose only objective is to basically transmit the message that you put into them. I'm going to make a message, put a message. I'm going to put another message. Now, pure data will by default connect these if you add them in quick succession, but I don't want them connected. So first, I'm going to make a message called start. Just type the word start into it. Next, I'm going to make a message called stop. Okay. So the idea here is that basically, if I send this message to TabWrite, TabWrite has a very special interpretation of particular messages. And it has a special interpretation for start and the word stop. If you send the word stop or start, it will do exactly that. It'll start recording the incoming audio or the incoming information to the table, and it'll stop when you tell it to. So we've hooked up these messages. Now what we need to do is we need to have a quick way to send those messages. The first thing I'm going to do is add a bang here. I'm just going to bang like that. And I'm going to connect that to the start. So what that will do is tell it to start recording. But the problem is that we never tell it to stop recording. So basically, it just starts. Actually, I need to turn on DSP. So if I start, it's like it's not going to stop. Actually, I guess technically it will stop. In fact, it looks like it stops pretty immediately. I think that's because it defaults to some. Actually, maybe it's just instantaneous. It might just be recording exactly what I put in at that moment, and then it immediately stops, which I don't think that that's really the case. I think what it's doing is it's actually recording. I'm not actually 100% certain what it does, but I will say we do need the stop signal because we don't know exactly what it's doing, so it's better to just be very clear about it. So what I want to do is basically I want it to start, and then I want it to record for exactly 1 second, and then I want it to stop. Okay, so what I need to do is add, I'm going to recall an object that we used in the past. I don't mention the object by name here. I can update the notes to do that because I'm sure that would be helpful to people. Oops. Those are the notes. We need to make a delay, and not like an audio delay, like a delay effect. We just need to delay this little message. So what I'm going to do is simply put an object. I'm going to call it delay. And then I'm going to add a number to it, 1000. What this means is basically delay by 1000 milliseconds, which is equivalent to 1 second. So basically, I'm going to send in this bang. and I'm going to say, hey, when you see this bang, transmit it after 1000 milliseconds. So basically, whenever I click this, it's going to sample for exactly 1 second. Notice that now it updates after the second. And I don't know what it was doing before. I mean, maybe it was already doing this because it does that by default. But again, that would totally depend on things that I've configured with pure data, like the sample rate and stuff like this. I want full control over how long the sample is, etc. So this lets me control exactly how long the sample is. So I can control that. As long as the size of this table or this array matches what my sample rate is here. So what'll be kind of interesting, well, I'll show that after when we can actually hear it. So right now we can't hear this because we're not playing it back, we're just storing it. So that's the first part of sampling out of the way, right? So we've sampled now. We've done that. I'm sampling. I mean, you may not believe me because you can't hear what's in this table, so you don't know what it's recording. But you can hear me talking, right? You can see that every time I speak, there's some data stored inside of this table. And then if I stop talking and record, you can see that it comes up blank, right? So there's nothing in this table, and that's because I was silent. So it didn't hear anything. There was nothing to record. And if I start talking again and I record, there's content there. So what we want to do now is, of course, we want to listen to this content because you don't have to take my word for it. It's definitely in there and we can play it back. So let's go hop down to that section. So, I mean, this is basically the last part of the sampler instrument. So the idea here is we're going to use tab read in conjunction with tab write, which we've never done before. So we haven't really used tab read. So this idea is basically going to allow us to play back the content of this array, all of these samples, as long as we dictate how the samples are played or read by the computer out to the speakers. So of course, first thing we're going to make, I mean, we do need tab read. And I don't know why I didn't mention this here. That's another addendum to these notes. Aside from the typo and the fact that you need a delay object. But also, of course, you need a DAC, a DAC. So, I mean, hopefully that's apparent if you're just reading the notes, but I'll add that in. So I would say, let's just go ahead and add that first thing, right? If we want to hear anything in pure data, we need to use a DAC. There's no way to get around that. Okay. The next thing we need is this object reference here. So again, I'm just going to copy it. I'm just doing, Control C basically. And I'm going to put another object and I'm just going to paste. Okay. So this worked, except I need to change the table name. Incoming. So now what this is going to do is it should read from the table called incoming and send the content to the DAC. Notice I turned off DSP there because I don't know what sound could be made. I don't want to hurt my ears. So just something to keep in mind. Okay, so tab read incoming, and with the tilde specifically, meaning I want you to read an audio signal. All right, now the problem with this is we still have a setup similar to when we first set up tab write. It doesn't know when it needs to write to the table. It doesn't know how fast it needs to write to the table. Same thing here. So it doesn't know when to read from the table, and it doesn't know for how long to read from the table, and it doesn't know how quickly to read from it, if that makes sense. Okay, so we need to describe all of those things for tab read. Okay, the way we're going to do that is this thing called a VLine function. Okay, so a VLine function is basically I mean, we've actually looked at it before in previous sessions. It's like a ramp. If I replace this, let's take a look. So let's get rid of the ADC really quick. Actually, I won't delete it. I'll just delete this line. Let's take a look at what VLine does. So if I do VLine tilde, right? So VLine, I mean, I can look at the help for it. it's basically like a line, and it makes ramps. So if I want to do something with a piece of audio, or I want to change something over time, these functions are very, very useful, because I can basically say, okay, I want a value to start here, and I want it to end here, and I want it to take this long to do that. And if you want to do that multiple times with different parameters, right? Let's say I want the value to start here, I want it to end here, and then I want it to go down and then up again, etc. VLine is the way to go for this kind of thing. So basically what we do is we're probably going to do something like this. We send it a message, or with these commas like this, it's a series of messages indicating how the line, the ramp, should behave. So what this is saying here is saying, okay, go to 1. So start at 1, okay, and then jump to, or no. Well, it's not saying jump to. It's just saying start at 1, the value 1, and stay there for 1,000 milliseconds, or 1 second. So that's the first instruction. That's how you read this comma. So, oh, okay, this is instruction number 1, okay? Let's see if we can get any information here. It'd be interesting. I think I can, oh, yeah, I started DSP. Okay, you can see it happening. This is pretty cool. So, okay, so I'm going to click this, and what will happen is it'll follow the instructions in this message. So it starts at 1 for 1 second, then it goes to 0 for 2 seconds, then it goes to 1, stays, or no, I think it should go to, I think it should go to 2,000, or I thought it would. I'm sorry, 1,000, from 1 to 1,000. I'm not sure what to think about this. Kind of interesting. Either way, we're not going to format our arguments this way, so we don't really have to worry about it. But the idea is that basically it's a series of instructions for the line to follow. And you can see this line travels from 1, stays there, goes straight down to 0. So you'd draw it like this. So over time, go like that. Then it would drop down immediately to 0 and travel for 2 seconds. And then it would travel from 0 to 1 over the course of, I guess, 3 seconds or 1 second. Oh, never mind. I think I understand. Kind of. Huh. It's interesting. I think it's saying basically after 2,000 total milliseconds. So this is saying like after 1,000 milliseconds, you should be at the value 1. After 2,000 milliseconds, you should have traveled from the value 0 to 0. But this 2,000 is including this first 1,000. It's a little confusing to read, but hopefully that kind of makes sense. You can see there are 3 instructions here with increasing values for the milliseconds. So 1,000, 2,000, 3,000. So basically it's saying this whole function should occur over the course of 3,000 milliseconds, which is, I guess, kind of makes sense. That's why it says are cumulative, not incremental. Anyway, this isn't super important. We can copy this. Oops, if I edit. So I'm just going to copy this from the help screen, which is a nice thing to be able to do. I'm just going to paste this in to my patch, okay? And I'm going to edit it because this line isn't very useful to me. What it's going to be useful for doing, though, is describing how to read from the table of values, table of samples, when I'm trying to play back the audio. So our case is very, very simple, which I describe in the notes. Basically, we want to create a continuous line function. So it starts at 0 and ends at the last value in the table. We're basically instructing the tab read how to look through the table. So we're going to say, basically, I want you to start at the first sample in the table and finish at the last sample. And I want you to read each sample sequentially over the course of 1 second. So what we're going to say is basically start at 0. And the last instruction I'm going to give you is to go to 1. Is to go to the last sample in the table, which is the 4,000 or the 44,100th sample, basically, in the table, okay? And then I want you to do that over the course of 1,000 milliseconds, right? So I want you to take 1,000 milliseconds to go from 0 to 44,100. The reason this is separated as an instruction is because you're basically, the first instruction is always telling the line where to begin at. You can specify a number if you want to here, like a duration, but there's no reason for us to do that. We want only one duration, which is how long it takes to get to 44,100. We want to read 44,100 samples over the course of 1 second. Okay, so we're going to pass that into our VLine. That's an instruction. Okay. Put that here. Put the VLine here. Okay, and I plugged that in. So if I click this message box, what's going to happen is that it is going to play back the sample. I did not do it. What am I missing? Am I missing something else? 0, 44. Oh, whoops. You can't have a comma. Do not put a comma. Yeah, that it does not know how to interpret that instruction. Oh, whoops. Sorry, click the wrong thing. Well, now this is empty. So if I click this, it does nothing. Let's record something again. So I'm just going to continue talking. Oh, whoops. I disconnected my ADC. Sorry about that. Actually, this would be kind of cool. We can see exactly what this VLine looks like, which is pretty interesting. Since it's an audio signal, technically, I can pass it into tab read. And I can just hook up the bang to this. So when I click this bang and it records, it should record. Yeah. I mean, it doesn't really make any sense, I guess, the way it looks here. But yeah, I mean, basically it's just a line. It's not really observable. Okay, not the greatest thing I've ever attempted to do. Let's put the DAC or the ADC back to my microphone. I think there's a better way to demonstrate what the VLine does with that preview like that, but it's eluding me right now. Not really getting that picture. All right, so essentially what I'm going to do is I'm going to record my voice again so that we get content back in the table. So you can see there's samples here representing my voice. And all I'm going to do is click this. I don't know if you can hear that. So if I can record something. I
can't hear it.
Oh, you can't?
No.
Ah.
Let me try, like, put it again.
Okay. Can you hear that?
I'm not sure. I hear something, but I'm not sure.
If I play it over my speakers, you'll be able to hear.
Remove my headphones. I'll play it over my speakers. It's going to be a little loud.
So if I can,
yeah. So I can basically just click this, or I can re-record again, and I can get more sample information. And I can just click this out. Get more.
Okay, I hear it.
Yeah. So I want to show one last thing before we kind of conclude. It's what I alluded to before is this idea of like sample rate conversion
reduction and stuff like this. But basically what I want to demonstrate is, this sample rate I'm kind of in control of, right? So I control what sample rate is used to capture my voice, and then I control the size of this table that I'm sampling into, and then I can control how I read it back. So how quickly I read back these samples. So what I want to show really quick, first of all, is just this idea. So I want to take, let's imagine if I change this and I take 2 seconds to read from the table. So what happens? So I have this sample recorded. Let's try this. Oh, here, let me.
This is basically called sample rate reduction, or well, it is sample rate reduction, but it's basically slowing the rate at which we read the sample back by just slowing down. Yeah, I mean, by doing exactly what I just said. So instead of reading the sample over the course, reading all of the samples together over the course of 1 second, we're going to take 2 seconds to read it. And I'll play over my speakers so you can hear what this sounds like. So I'm going to play it. It sounds like someone really slowed down. That's basically half time, right? It's taking us twice as long to read the sample. Again, and I can just, of course, keep clicking that. And then simultaneously, or similarly, you'd think, oh, well, what if I want to read it twice as fast? Well, I'll just take only half a second. Whoops, I totally lost my stuff. Oh, there it is. Okay. If I just take, if I read the sample twice as fast, then you can imagine what's going to happen. This is going to be even faster. Yeah. So, yeah, it is like kind of the chipmunk style. Like Alvin, this is basically what they did for like Alvin and the Chipmunks and stuff, is they just, they're just playing the audio back faster. So that's why it kind of sounds like that. So this stuff basically you can imagine in an instrument context, right? Like what if I had a sequencer like we built before, or a way to automate changes in, sample playback rate, right? So if I changed over time, like how quickly I read the sample back, all of a sudden, this could be kind of like different notes. Like if I change this to 800,
and I can get more.
And then I change it to like 400 or 300. Now it's not only is it faster, right, but it's higher pitch.
Yeah.
So all of a sudden I could make like an instrument, like a musical sort of melody out of just changing the rate at which I played this sample of my voice back. And then I could sample a new version of my voice and then play that, and it would do different things and sound different, and yeah, we can make it even really, really slow, which you probably can't even hear. That's so low.
Yeah, no, but I can hear it.
Oh, great. Okay, good. Yeah, so going back to this, this is one way to do kind of sample rate manipulation to get really cool effects with our sampler. So one last thing I want to show, which is kind of cool, is just totally changing the sample rate to begin with. So what we're currently doing is basically the sample rate that is coming in for our audio quality is the same. We're just changing the rate at which we interpret the samples and play them over the speakers. So what I want to do now is I want to actually change how the audio is incoming for my microphone. So what I'm going to do is I'm going to drop this like 9,000. And I'm going to apply. I'm going to hit OK. All right. And then what I'm going to do is I'm going to change this table to consist only of 9,000 samples. Okay. And then what I'm going to do is I'm going to re-record. So first of all, you already see, right? The lines are like really thin looking, like they were really solid and black. Now they're really thin. That's because there's less values. We cut the values down by like 1/4. So I'm going to re-record my voice again. You can see that there is a lot of samples in here. 9,000 is still a pretty big number, but there's still significantly less than there were before. So I've hit OK. I've confirmed all that. Okay. So again, I'm going to do another sample of my voice. We can use this. All right. I'm still recording though for 1 second. Like you can see the delay here on this bang. It stops after 1 second. So I'm still recording 1 second's worth of audio, but the difference is that I'm only using 9,000 samples to represent that same audio. Now what I'm going to do is modify this VLine, and I'm going to change it to be 9,000. So instead of 44,100, I'm only reading 9,000 values from this table. So I need to change this to 9,000, and I'm still going to take a second. So let's listen to what this sounds like. So again, so I don't know how well you can hear that over Zoom, but it's going to sound, it's like way worse quality. It sounds like I'm on a telephone, basically. It sounds like, it sounds like kind of like I'm in like a conference call. I don't know. That's what it sounds like to me.
Yeah, it sounds like that.
Yeah, okay, great. Yeah, that's good. I mean, we can go even further down. I mean, you can keep going down pretty far, pretty extreme. So I went down to 2,500. Gonna go in here to my audio settings, set this down to 2,500 too. I'm gonna hit OK. I'm gonna re-record. So I'm gonna re-record again. Record. I'm just trying to get a nice looking sample. How about this? Or maybe this. Let me get a better sample. Sample. Okay, that's pretty decent, I guess. I would want a better one. Oh, I can't get a good sample. Oh, whoops. That's because I forgot to change the array. Oh, no, I did change the array. I'm just not doing a good job here. Okay, that's a little bit better. Still not great. That's better. All right. Last thing I'm going to do is I'm going to adjust the VLine again to be 2,500. So this you should really be able to tell. It's going to be very obvious. This is terrible quality. So it sounds like I'm inside of like a cave. I mean,
That sounds like the TV in the background.
Yeah, it does. Yeah, right. It's totally unintelligible. That's because we're losing a ton of things. We're losing dynamics, frequency content. Yeah, we're losing so much of my voice at that point. This would be a much better sample, by the way. Let's try this. We're losing so much. I mean, it sounds just totally unintelligible. Yeah. And we can play that also faster. This would be really fast. Now it doesn't even sound like anything. It just sounds like a weird, I don't know, it sounds like a frog. And then of course, last but not least, we can play it really, really, really slow. So, okay, but that's it. This was sampling. I hope that was enjoyable. I hope that's something.
Yeah, it was.
Oh, that's great. Yeah, maybe something interesting for folks out there, or try this out. I think it's really interesting. It's really fun to do. There's tons of experiments you can do with it. I mean, honestly, the world of sampling is pretty endless. There's all kinds of phenomena that you can observe and really interesting stuff. It makes for really interesting instruments. I mean, that's why there are so many samplers out there. But, yeah.
All right, sounds good. Thank you so much, Paige. And like I said, we're not gonna be meeting in November, but all these recordings are in Facebook or YouTube. So please feel free to just review them, and maybe like some of them match with the other ones, but for the most part, they're all different. So you guys can just review them. All right. Sounds good. Thank you so much, Paige.
Yeah, thank you. I really, really appreciate it.
All right. Have
Bye.
a good night. Bye.